Sorry, my husband cut me off because he decided to call, so dang it. So one on top, one on bottom, and then two on the left and right edges. Okay, you'll see these a lot of time on geometry papers, which are papers about, or geometry work, anything with shapes. One hash mark, 1, 1. 1 equals 1 equals 1 equals 1. These marks are saying this edge is equal to this edge, same size as this edge, same size as that edge. So congruent, same size, same shape, same size, same shape, because 1 equals 1 equals 1 equals 1. 1 equals 1. This length is equal to this length. But 2 and 1 are not equal, are they? That's because 1 equals 1, but 2 equals 2. Opposites. Kind of a neat fact, I think. But I'm a math nerd. All right, this last one. We all know that it is a square. Now, when we're younger, they just teach us square, rectangle. But starting in 3rd grade, we start having to learn their attributes, the ways to describe, the characteristics of them. So, a square's attributes, parallel segments. Let's go. Extend your edges, the side, left and right ones. Parallel, yes or no? Yes, because they run side by side. Then let's extend the top and bottoms. Parallel, yes, so parallel once, parallel twice. 2 sets of parallel segments. What do we call that? Parallel, parallel, parallelograms. Look, now I'm going to be lazy. See above. That's the great thing about taking notes. Once we read or write it and say it a few times, it's not language class. We don't have to do sentences. Hooray! Not for this anyway. Right angles. What do right angles look like? Losers. Is this a capital L? All right, so there's a 90-degree right angle. Is this an L? Capital, yeah. There's 2. 3. 4. Again, quad. 1, 2, 3, 4. 4 edges, 4 vertices, 4 angles. They just happen to be right angles, 90 degrees. Again, I messed up and left something off. That's what happens when you're in a hurry. 4. Look, we'll try a different word. Equivalent. EQUIVALENT. 4 equivalent edges. What is equivalent? Equal, yeah. Kind of like right here, we said they were congruent. Same size, same shape. Well, if you're the same size and the same shape, you're equal, you're equivalent. And again, while I'm saying that, I'd probably be up walking around, you know, did they do what I did? Is it legible? Do I need them to rewrite? So, before we're done, all of these shapes are polygons because, tell me, why are they polygons? I don't know. Edgar, I'm making up a name now. Yes, they are all flat. They're all two-dimensional. Henry, why else are they polygons? Oh, they're closed. That's right. No openings. Good. Dallas, why else are they polygons? Yes, they're straight-edged. If there's a curvy one, it's not a polygon. All right. So, Zoe, why are they quadrilaterals? Because they have 4 edges, okay. Why else are they quadrilaterals, Anthony? 4 vertices, good. Letty, why else are they quadrilaterals? 4 angles, good. All right, so they're polygons. They're quadrilaterals. What makes a trapezoid a trapezoid? What is his special attribute? What is his special description? Yeah, he's a quad with only 1 set. If you only have 1 set of parallel segments, you're trapped on that one-way highway. What do we learn all the other quadrilaterals had? The last 4. 2 sets. If you're parallel once, you're parallel twice. Parallelogram. Parallel, parallel, parallelogram. Parallel, parallel, parallelogram. Parallel, parallel, Parallelogram. Parallelograms. Which of your quadrilaterals have right angles? Squares, yeah, and rectangles. So that's a special attribute. Which of your quadrilaterals have 4 equivalent sides? Yep, the rhombus and square. 1 equals 1 equals 1 equals 1. So these guys have an attribute in common of right angles, but these guys share the attribute of 4 congruent edges. Kind of neat.